Let us take the third question on shear force and bending moment. Here we have a question in which it is given a beam ABCDEF is 12 meter long, is supported as shown in figure, and here we have to draw SFD and BMD, shear force diagram and bending moment diagram for this beam. So we have this question in front of us. Now we would be writing the data for this. As we can look into this question, it is different from the questions we have solved previously. Here we can see an element is there, a section which is 1.5 meter in width and 1.5 meter in height. Over this section we have 40 kilonewton load acting downward and 20 kilonewton load acting horizontally towards left. So now we have to convert this into an equivalent diagram. Now how to convert that? For that I would be taking moment at point C. I'll say that taking moment about point C. Here my convention will be clockwise moment positive and anti-clockwise moment negative. So therefore I will say moment at C is equal to, here I have 40 into 1.5 clockwise minus, because this 20 will produce anti-clockwise moment, so minus 20 into 1.5, and my answer is plus 30 kilonewton meter. Now since my answer is positive, it means at point C there is a moment acting because of this bracket which is given in the diagram, and now that value of moment is 30 kilonewton meter. For that I would be drawing this beam again and showing this value of moment, or you can say couple. So let us start solving this question. We are into question number 3. Solution. I will draw this beam once again. So here is the diagram of the beam which is given. I have replaced this bracket with the moment acting at point C, and the answer which I have got, that is 30 kilonewton meter positive, so it is clockwise moment. At the same time there is downward load of 40 kilonewton acting at point C. Now this is the complete beam which we have, and based on this we have to draw the SFD and BMD. So I'll say that there will be reactions at A and reaction at E. So my first step is step number 1, calculation of support reactions. Here I have RA and RC as upward, RA plus RC, 20 into 2, that is the UDL into point load. So here I have minus 40 kilonewton. Again here I have minus 40. Next 15 into 5, that is 75 in the downward direction, so minus 75 kilonewton, and here I have 30 kilonewton is equal to 0. So therefore RA plus RC will be equal to, here this is my summation of moments, or you can say summation of Fi is equal to 0. Upward force is positive and downward force is negative. Here I have minus 80, minus 75, that would be added, so it becomes 155, and in 155 if I add 30, that becomes minus 185. If I shift it onto the other side, so it is plus 185 kilonewton. My equation number 1. After this, I will say that sum of moments of all forces about point A is equal to 0, where I will take clockwise moment positive and anti-clockwise moment negative. So I have RE, reaction at E, into the distance between A and E, that is 10.5. So minus RE into 10.5. Then here I have 15 into 5, that is 75, acting at half of 5, that is 2.5, and it is in the downward direction, so clockwise moment. So here I have plus 15 into 5, that is 75, multiplied by its distance from point A, that will be, here it is 2.5 plus 1.5, that is 4 plus 4, 8. And here I can see one more clockwise moment, 30, so I'll write it as it is because it is positive in the clockwise direction. Next, 40 kilonewton load will also produce clockwise moment, so 40 into 4. Then I have 20 into 2 acting at half, that is 1, so plus 20 into 2. So from this I am getting reaction at E. It comes out to be 113.33 kilonewton. After we put 113.33 kilonewton in equation number 1, I will get RA as 71.67 kilonewton. So here I complete my step 1, where I have calculated the support reactions. I can write the values here. After completion of step 1, we will go on to step number 2, that is shear force calculations. In shear force calculations, first I will draw the sign convention. Upward force to the left, downward force to the right, both are positive. Downward force to left and upward force to right, both are negative. So I will start SF calculation with point A. So SF at point A will be equal to, here my assumption is that the section is just to the right of A. It is here. So now if I am taking this section, to the left of that I have only one force and it is upward, so positive. So that is 71.67 kilonewton. Then after this I will be calculating shear force at point B. And that value is, my section is at point B. So here I have 71.67 as upward, 20 into 2, that is 40 into downward direction. So here I have 71.61 minus 40, that will give me 31.67 kilonewton, positive sign. Next, SF at point C, now that will be equal to, this shear force between B to C will remain constant, but the moment I take section to the right of C, here I have 71.67 minus 40 and minus 40, that gives me 8.33 negative kilonewton. After getting shear force at point C, now this shear force will remain constant between C to D because there is no load. So shear force at point D will be same as shear force at point C. Now after this shear force at point E, here also I will be having two values. At first to the left of E, where I am not considering reaction at E. So here I have SF at point E is equal to 71.67 minus 40, again minus 40, and then 15 into 5 downward, so again it is negative, so minus 75. So here I get my answer as 83 point, which is negative, minus 83.33 kilonewton. Now we will get one more value of shear force at point E. That will be by taking the section to the right of E. So here I have, if I take the section to the right of E, RA, which is upward 71.67 minus 40 minus 40 minus 75 and plus 113.33. So that gives me an answer of plus 30 kilonewton. Now this shear force will remain constant up to point F because we don't have any load between E to F. Now once we have calculated shear force at each of the points, we can easily draw the shear force diagram. So for that I will draw the beam once again. This is the beam which is given in the question. Now to draw shear force diagram, we would be projecting the point downwards. Next, the length of shear force diagram will be equal to the length of the beam. Shear force at A, the value which I have, it is 71.67 kilonewton positive sign. So here I have positive sign, means it would be above the line. Next, at point B, I am getting shear force value as 31.67 kilonewton, again positive. Now as there is UDL between A to B, this shear force will be an inclined line. Next, between B to C there is no load, so shear force will remain constant. After this, at point C we are having shear force value as minus 8.33 kilonewton. This shear force will remain constant between C to D. At point E, we are having two values of shear force. One is minus 83.33 kilonewton and the next value is plus 30 kilonewton. Now we have reached up till here, that is 8.33 kilonewton at point D. From D to E there is UDL, so shear force will be an inclined line. Next, at E we are having two values, so from minus 83.33 it goes into plus 30 kilonewton, and between E to F, since there is no load, this shear force will remain constant. So now here I have positive and negative sign above the line and below the line respectively. So this is the shear force diagram which we have. And here we complete step number 2. Now step number 3, calculation of bending moment. Here we have bending moment calculations. So now I will be drawing the sign convention first. Clockwise moment to left and anti-clockwise moment to the right, positive. Anti-clockwise moment to left and clockwise moment to the right, negative. So here I can say, since we have this beam which is supported at A and free at F, so at the support the bending moment will be 0. So here I have, first of all, moment at A is equal to 0 since it is simply supported. Next, at the free end, which is F, at point F bending moment will be 0 because it is overhanging portion, and we know for overhanging portion the moment is 0. So bending moment at F is equal to 0 since it is overhanging. Now I will first calculate bending moment at point B, and that will be equal to, here I have reaction at A whose value was 71.67 kilonewton, and reaction at B whose value was 113, reaction at point E 113.33 kilonewton. So if I am taking the moment at point B, I have RA and this produces clockwise moment. So if I take the section at B and to the left of section I have clockwise moment, so that has to be positive. So here I have 71.67 into 2 minus the UDL value given here is 20 kilonewton per meter, and the next UDL was 15. Now if I am taking the moment at point A, it is 20 into 2 multiplied by 1, which is half the distance, and it is producing clockwise moment to the left. So here I have, if it produces here at point A and at B the moment would be anti-clockwise, so negative. So minus 20 into 2 into 1. So moment at B I am getting the value as 103.34 kilonewton meter. Next I will calculate moment at C. Now for moment at C I would be getting two values, one in which I will not be considering this 30 kilonewton meter moment, and the other value in which I would be considering this. So the first moment at point C, I will call this as to the left of C, that is equal to 71.67 into 4 20 into 2, that is negative, and the distance is 3 meters from point C. So minus 20 into 2 into 3. So here if I calculate the answer, this comes out to be 166.68 kilonewton meter, again positive. Next I will calculate moment at point C considering the external moment which is acting, that is 30 kilonewton meter. So I will get this as, it will be 166.68 plus 30, that comes out to be 196.68 kilonewton meter. So I have got the value of bending moment. Two values is at point C. Next, moment at point D. That will be 71.67 into, from D to A the distance is 5.5. Next, 20 into 2, so here I have minus 20 into 2, that is the UDL into point load, multiplied by distance from point D is 1 plus 2, 3, 3 plus 1.5, that is 4.5. Next, here I have minus 40 into 1.5 plus 30 kilonewton meter, which is acting in clockwise direction at point C. So I get the answer of moment at D as 184.18 kilonewton meter. Again, this answer is also positive. At last, I am left with moment at E, that will be equal to, if I take my section at point E, 30 kilonewton is producing clockwise moment. If to the right I have clockwise moment, that has to be taken negative. So here I have minus 30 into 1.5. And this value comes out to be minus 45 kilonewton meter. So here I have all the bending moment values. Based on these values, we can draw the bending moment diagram. I am drawing the bending moment diagram. Its length should be equal to the length of the beam. At A, the bending moment is 0. At B, it is plus 103.34. So I will be marking the values respectively. At A, bending moment is 0. At F, it is 0 because here we have overhanging portion. B, the value is 103.34. Next, at C, I have two values of bending moment. The first one is 166.68 and the other value is 196.68. Then at point D, the value is 184.185. At E, I am getting the value as minus 45. So now, these are the points which I have marked for the bending moment. As I see in the diagram, from A to B, we have UDL. So shear force was an inclined line. Bending moment should be a parabolic curve. Between B to C, here there is no load. Shear force was a straight line. So bending moment should be an inclined line. Next, bending moment increases from 166.68 to 196.68 at point C. C to D, we don't have any load, so it is a constant line. In bending moment, it would be an inclined line. Between D to E, here we have the shear force is changing its sign, and since there is UDL, so here we should be getting a parabolic curve. Finally, between E to F, there is no load, shear force was a straight line, so bending moment should be an inclined line. Here I have to mark that between A to B and between D to E, it is parabola. Parabola is from D to E and from A to B. Here positive and negative bending moment. So here we have completed the bending moment diagram. And as mentioned in the question, they were telling us to calculate or to draw the shear force and bending moment diagram, and with this we have completed the problem.